As we move into our new module, Module 5, Section 1, we're going to be looking at quadratic equations. We'll start off with the principle of square root, completing the square, and then problem solving. Now, as always, we should be looking at the textbook. And actually, I have video lessons on the textbook if you'd rather do it that way. But looking at your textbook is going to be a very, very useful tool. So, with that in mind, let's get started. Now, as we look at our first example, and I'll be writing these so that you can see them well here. We have x squared equals 81. Now, the way in the past we would solve this, we'd put it into standard form, transpose that, equate it to 0, and we see this is the difference of perfect squares. That factors into its conjugates. And we get then x equals -9 or x equals 9. Now, that was the way we did it in the past. But since we've done radicals, we can look at this way. We can take the square root of both sides. Square root of this side is going to be x, and the square root of this side is going to be 9. But notice when we do it that way, we only get one of the two possible answers. So from now on, whenever we take the square root of x squared, we're going to say there is a possibility that we get a negative and a positive value. So from now on, we'll say x equals plus or minus 9. It's plus or minus the square root of 81, which is plus or minus 9. That way we ensure we get the negative root as well. Okay, so let's follow that and do our next one. 4x squared equals 28. Now, to start solving this, we have to isolate the x squared. So we divide both sides by 4. We then get x squared equals 7. So the next step is you take the square root of this side plus or minus the square root of that side, and you then get x equals plus or minus the square root of 7. Going on to the next one. Well, what I'm going to do is take this negative term, bring it to the other side, make it positive. So this will be a positive x squared, and it's going to equal 5. So I'm taking this, bringing it to the other side, and just writing it this way. Okay, so we want to isolate the x squared. We divide both sides by 3. We get x squared equals 5/3. Now what do? Well, we take the square root of both sides. This is going to become plus or minus the square root of this. So we have then x equals plus or minus the square root of 5. Remember, I can write it this way, over the square root of 3. Now, we never want to leave a radical in the denominator. So what we need to do here is to rationalize our denominator. That's why we had that technique. We're going to multiply this fraction by 1 in the form of 3 over 3. So this then becomes x is equal to plus or minus the square root of 15 over 3. Now, theoretically, this is correct, but it's not in an acceptable form. In order to get rid of that radical in the denominator, we have to rationalize the denominator, which is what we've done. Going on now to example D. Let me write it out for you. 16x squared. Now I'm going to take that 49 and bring it over to the other side. Save a little bit of room. So this becomes a negative 49 on that side. I'm going to isolate the x squared by dividing both sides by 16. Now I'm going to take the square root of this side and I do plus or minus the square root of that side. So this side will become x. Now this side is going to become plus or minus. Now the square root of 49 we know is 7, but there's a negative under the radical sign. So again, going to the previous module, this is going to become 7i, and this will become 4. Now I see the way they have it written down below. They have 7/4. I is written out here by itself. Well, this is acceptable, and so is this. This is the preferred way because this is an imaginary number. All right, now as we look at letter E, when I first looked at letter E, well, let's write it out first. X squared plus 4x plus 4 equals 10. Now that's not in standard form, but this part, do you recognize what that is? Think about it. That's a perfect square trinomial that will factor into x plus 2, the quantity squared, equals 10. So instead of just having a single term here, we have a binomial that's squared. But we can use that same principle that we used before. We can take the square root of that, and that just gives us the radicand. And then we take the plus or minus square root of the other side, and we get plus or minus the square root of 10. Now, all we have to do is transpose this, and we get our answer. X equals negative 2 plus or minus the square root of 10. Wow. So it looked a little daunting in the beginning. If you recognize that this is a perfect square trinomial, which will factor into a binomial square, then use what we've just shown you to get your answer. All right, let's do this next one now, which is x plus 4, the quantity squared, equals 5. Now, once you get it into this pattern, again, it's taking the square root of both sides, plus or minus the square root of 5. So this becomes x plus 4 equals plus or minus the square root of 5. We're just going to transpose the 4. We get x equals a negative 4 plus or minus the square root of 5. Wow. Now we're going to use this technique in our next part of our lesson here. So let's set it up. Now we have a x squared plus bx plus c as the standard form of the quadratic expression. Now, if this is a perfect square trinomial, that will factor into x plus a term here that is going to be squared. Now, what they want us to do here, and I'll write this out here as well. So we have x squared plus 10x plus something here that we want to factor into a binomial square. So what we're going to look at is what did we do in the past when we took a binomial square and got a perfect square trinomial. Well, let's just do one up here. So we have x plus 4, the quantity squared. Well, we said square that, and that gave us x squared. We said multiply these two together and double it. That gave us a positive 8x. And then we said square this term here, which gave us a 16. So this is a review of something we did in an earlier module. This is a perfect square trinomial. So here they're giving us part of a perfect square trinomial. Well, how did we get this term here? Well, we squared the x, so the x is there. And notice they're giving us that x. Now, how did we get this b term up here, this b term right there? How did we get that? Well, we multiplied this times this and then doubled it. So if we doubled something to get the b term, how do we undo the doubling? Well, we undo it by dividing by 2 mentally. So when we divide this by 2, what do we get? A 5. So once again, we would square this to get that. We would multiply these two together and double it to get that. We take away that now. So we always divide our b term by 2 to get this, or multiply by 1/2. Now, how do we get our c term here? We square this, and I'll change colors here, and we get a 25. So here they want us to put a 25, and they want us to put a 5 there. Now, I'm going to strongly suggest that as you do these, you follow this protocol, write it out this way, and then underneath you put your parenthesis in the square. Now let's do the next one. I set it up for you. Again, this is how I suggest that you do it. And we'll give you a moment here. So, how do we get this term here? Well, it's just an x that we will square to get this term. Now we know our sign is going to be negative from there. And what did we say? This is our b term. We had to multiply this by 2 to get it. So we're going to divide by 2 now. To get what our binomial will be. So whatever our b term is, we're dividing by 2 or multiplying by 1/2. So this is just divided by 2, and that's a good way to do it. Now, how do we get our c term? Well, we take this and square it. So this becomes 81/4. So here we're going to put 9/2. Let's see, this is 81 here. 81/4. Here it's the 9/2. Again, I like to do it this way. So we square this term, that's what goes there. Okay, now I'm going to clear this, but you have it as a reference in your booklet, because we now want to solve this equation. Let's write it out. X squared minus 6x minus 8 equals 0. We want to solve this equation by the process called completing the square, which is what we've practiced up here. This process that we did was called completing the square. So, step 1, you write your first 2 terms. You take your c term out of there and bring it to the other side as a positive 8. Just transpose your c term to the other side. Now, put your parenthesis that you're going to square. Now, what is needed to get this term? Well, just an x. How did we get our b term? We had to multiply these and then double it. So to find out what this is going to be over here, and it's always that sign right there, we take half of 6. What is half of 6? 3. Now, what do? We need to get our c term. Well, our c term comes from squaring a negative 3, which is a positive 9. So we are adding a 9 to this side of the equation. To keep it equal, we have to add 9 to the other side as well. So now this is a perfect square trinomial that will factor into this, and it equals that. So now we have x minus 3, the quantity squared, equals 17. Just adding these together. So we take the square root of that, and we get x minus 3, the radicand. And we take the square root of this side, and we get plus or minus the square root of 17. So what do we do now to solve for x? Well, we take our term from this side, transpose it, so we get x equals 3 plus or minus the square root of 17. And how did we get this answer? We got this answer by completing the square, transposing the c term, then making what's left into a perfect square trinomial. That was completing the square. Then taking the factor of that and then going through our process. Now this next one's a little more challenging, so let's write it up here. So it's x squared plus 3x minus 5 equals 0. So we go x squared plus 3x. We're going to transpose the negative 5, becomes a positive 5. Put our set of parentheses. This is the easy part. The x goes there. This sign goes there. Now what's half of 3? Well, 3 halves. Now, how do we get our c term? And I'll change colors. Well, we have to square this. So this becomes a positive 9/4. So we have to add a positive 9/4 to the other side. Now here's the little tricky part. We have to add these. We have a fraction and a whole number. Well, in order to add these, we have to make the 5 into something that is with a denominator of 4. So that becomes 20/4. So 5 is 20/4. So we then have 9/4 plus 20/4, which will give us 29/4. So we are here, x plus 3 halves, the quantity squared. This was the little tricky part. Okay, we take the square root then of this side, and then plus or minus the square root of that side. Well, this is irrational, so that we get the square root of 29. But 4 is a perfect square. That will become a 2. And now we have x plus 3 halves, and then this is plus or minus this. And now how do we solve for x? Well, we just take our 3 halves, bring it to the other side as a negative 3 halves, plus or minus 29/2. Now in MathLab, as you put these in, that's the tedious part. You have to put them in one at a time. Now the book is showing all of this over 2, but this way is perfectly acceptable. And I like to do it that way. Okay, let's go on. Now this last one, I'll write it out here for you. We had cut off the 0 part there. Again, in order to use the technique of completing the square, in the next section we're going to do a way to do it that you wouldn't use completing the square. But let me just show you this one. We have to get rid of our fraction of the coefficient of x squared. So this then becomes x squared plus 9x/2 we're going to transpose that as a 3/2 over there. Okay, I'll work it some more. So if we multiply this fraction by 1/2, that gives us our b term, which is 9/2 times 1/2 gives us 9/4. To get our c term, we have to square the 9, get 81, square the 4, get 16. So we have to add that to both sides. Now, in order to add this together, I have to have common denominators. So the 3/2 here becomes 24/16. I'm just multiplying both of these by 8. 8 over 8 is 1. So I get 24/16. When I add these together, I get a 105 over 16. So that's where we are now. Now I take the square root of this, and I get x plus 9/4 equals the square root of this, and I get plus or minus the square root of 105 over 4. I'm taking the square root of my denominator. Now to solve for x, I just take this term, transpose it, and I get a negative 9/4 plus or minus 105 over 4. Or you can put it all over 4. Again, this one was rather tedious, but there's the work. And the nice thing is, if you want to go back, try it on your own and see what you get, or you can rewind the tape to go back and watch it again. Okay, let's go on to this, which is problem number 3 here. And I have cut it off a little bit, but you can see it in your booklet. And in order to do this, I had to go to the textbook and find out what my formula is to do this. Well, if you go to your textbook, the formula for interest and amount is A equals P times 1 plus R to the T power. So that's the formula that we need for this. And they're not giving it to us here, but I'm giving it to you. I got it from the textbook. So this is going to be 3630. The principal was $3,000. 1 plus R. We didn't know what R was, but we know that T is 2. So we want to isolate the R, and we start to do so by dividing both sides by 3,000. So here it cancels out. And when I actually do this and take the, let's just write this out here. This is going to be 3630 by 3,000 equals now 1 plus R, the quantity squared. Well, the key to this is, how do I get the R out of this being squared? Well, we take the square root of this, and we take the square root of that. Now, I would take this, divided by this, get a number, and then take the square root of that. And it comes out to be 1.1. And we get 1 plus R. Now, you get a plus or minus, but we reject the minus. That's not going to work for us. So we just use the plus value. So now we subtract 1 from both sides, and we get 0.1 here equals R. Now, we want to know a rate in percentage. So we take our decimal add a 0, and then a percent sign. So our answer for number 3 is 10%. And going on to the last one, we have this formula. S equals 16t squared. And we have an object that's going to fall 740 feet. We're going to divide both sides by 16. Take the square root. We get t, and there's a negative, but we reject that one. And this comes out to be about 6.8 seconds. And again, I could spend more time, but you can look it over, pause. Again, you want to know how to do your quiz-me's. You're practicing quiz-me's in preparation for the test, and this will be background for this unit. All right, let's go on.